This is Geometry A, Unit 5, Lesson 3. We're examining something called the side-side-side congruence theorem. The basic idea is this: are there shortcuts for demonstrating or proving that two triangles are congruent? Or do we need to use corresponding parts of congruent triangles CPCTC every time and prove all three pairs of angles and all three pairs of sides are congruent? The answer to that question is there are several combinations of three facts that I can use as shortcuts rather than using all 6 facts. And so the question we're going to address today, is it sufficient to say if I have two triangles where all 3 sides are congruent, then the triangles are congruent? Or another way to say that is, if all 3 sides are congruent, then all 3 angles will necessarily be congruent as well. Right? So I'm using the GeoGebra graphing calculator, the geometry setting of it. And we're going to start with a triangle. I'm going to draw a polygon here. Use the polygon tool to draw a triangle. ABC. You notice you can grab the move tool and move things around. Okay? And change the triangle any way you want. We're going to use that. We can use it to move the labels as well around to make them more convenient. Okay, but what I'm going to use is I'm going to use the construct tool, and we're going to construct, actually we're going to use the compass tool under circles to construct another triangle by measuring all 3 sides. So I'm grabbing the compass tool, I'm going to put it on A and then on B, and that makes a circle of radius AB. I'm going to move it over here and plop it right there. There's a circle D whose radius is the length of AB. Then I'm going to put a point on that circle. Anywhere on the circle will do. I'm going to put it up here, E, and I'm going to draw a segment DE. Now, I know because I measured with my compass that DE now has the same measure as AB. All right, so then let me use the move tool to move this in a more convenient place here. I'm going to measure BC with my compass. So compass tool, BC, and it gives me a circle of radius BC, and I can put it on either end. I can put it on E or D. I'm going to put it on D. Okay, and so every point on the greater circle there is the same distance from D as B is from C. Okay, and then finally I'm going to use my compass tool to measure the final length AC. AC. And this one I'm going to put at point E. And you'll notice this circle intersects twice the last circle I drew. I'm going to pick one of those points. Okay, I'm going to pick this one right here. I'm going to pick this one over here on the left. And now I'm going to draw a segment EF and DF. And the question becomes, are the two triangles that are formed, let me use the polygon tool to trace DEF here, are the two polygons, the two triangles, congruent? We measured with our compass the 3 sides. Notice I didn't measure any angles at all. I just measured sides. Well, let's find out. First, I'm going to go down to the measure set of tools. I'm going to measure distance here. Distance from A to B, 2.4, and D to E, 2.4. Distance from B to C, 4.3. Distance from E to F. Oh, the B to C, it should have been D to, yeah, because I put it on the other side. D to F, there we go, 4.3. And BC corresponds with DF. AC corresponds with 4.5 EF. Okay? And so all the sides are the same length. Now I want to know if the triangles have the same angle measures. So I'm going to use the angle measurement tool. Okay? And I'm going to measure angle A by clicking on its 2 sides. 69.9. Going to measure angle D between 4.5. No, I'm going to measure angle E. E. And it is 69.9. So A corresponds to E. I'm going to measure angle V, 78.5. I'm going to measure angle D, 78.5. I'm going to measure angle C, 31.6, and I'm going to measure angle F, 31.6. Try that again. 31.6. There we go. Okay. So the angles are the same size, and so we can say triangle ABC is congruent to triangle, actually, EDF. EDF. And what's more is, it doesn't matter what I do to the triangle. I can change it, and you'll notice they still match. 51.9, 51.9, 101.7, 101.7, 26.4, 26.4. And so yes, side, side, side is sufficient to prove these triangles are congruent. No matter what I do, the triangles remain congruent. All the angles and all the sides are the same. Okay? So side, 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 sufficient.